Hey guys, welcome to another video, and today we have tiny little GTX 1660Ti from Palit, StormX model, 6 gigs as you would expect from 1660Ti. And yeah, but I mean it's small, but the card is decent, I would say. It has this additional plate covering all the components on the PCB, so it's trying its best to compensate for the small size. I guess some people can relate. Yeah, so what's wrong with the card? I don't know. I have just disconnected the fan because I'm pretty sure we'll disassemble it. And let's see what's wrong with the card. So let me remove the screws. Actually, I'm not even bother speeding it up because it's probably super quick and easy. Those two screws, like extra screws, and 4 on the core, nothing else, so that should be pretty quick. And we'll have the card disassembled shortly. Takes a few seconds only, so we might as well do it together. Okay, I just need to put the screws somewhere so I don't lose them. And we have the card open. Let me just slowly disconnect it from the PCB without damaging any connections or anything, or the BGAs. Okay, a little bit dirty. Used card. Maybe it was open because there's missing piece of thermal pad here, but it's not on the memory chips, so most likely someone opened it before anyway. Alright, that's not surprising, that's expected. And we are back with the multimeter. Let's do some basic measurements. Let's check the resistances and see if we have any shorts on the card. So starting with 12 volts on the slot, it's fine, and 3.3 is fine. Then 12 volts from the PCI Express is fine. Then we have a coil here, but this will be probably connected to our 12 volts most likely, or 3.3, no, 12 volts. It's fine, and so that means the fuse is okay, but let's check it anyway. Not a good contact. It's fine. We have continuity, so here we have some coil, 5 volts maybe. Resistance 0.9k, that looks okay. Then we have some twin coils here, so probably PEX and 1.8. Let's check this one. We have, we don't have a good connection. First of all, we have hundreds of kilo ohms, so that's probably 1.8, and this most likely will be PEX. 12 ohms, that's healthy for PEX. So far looking good. Anything else we can measure here? Let's finish the resistance measurement. By the way, what's the resistance to ground? .35, let's say. So let's check. We cannot check it here. I mean, we probably can, but it's not very convenient. Let's check it on the other side. So let's grab the ground again, and let's check those two coils. So those probably for memory. Oh, is it memory? That's kind of low. 5.5, so like 5 ohms. That's super low. I mean, it's not that short, but it looks suspicious. We had on the channel one case with RTX 2060 or 2060 Super, I believe, where the resistance was also low, like 9 ohms or something, and I found it suspicious, and turns out that it was perfectly fine. And the card was working. The problem was the BIOS actually, so after flashing the BIOS the card worked. So I mean, it's probably okay to power it on and see. Let's see. Oh, okay, so we have resistors here. We don't have the terminals from the coils. Okay, we have two, so like 1.8 ohms, so looks like we have some resistance on the core as well, so it's not shorted, so that's very promising. 1.5 ohms, I guess. I don't have a good contact here. Yeah, something similar. And here. Okay, it measures the same. So the core resistance looks really okay. I'm worried about the memory, but as I said, it's not that short. We have some fuse, by the way, here. Let's check it as well. And we have continuity, so I don't see anything wrong so far. Let's get back here. Let's check the BIOS chip. LED number 8 is here. And again, perfectly healthy. So let's check the data lines maybe quickly. Zero point 6. No, it's rising. 68. Oh, that's surprising. 70. Why it's rising? Usually the reading is quicker. Okay, it's the same. Here it's more or less the same. I mean, I'm not gonna wait for each of them to fully stabilize, but looks like it's getting the same direction and stops at the same voltage, more or less. Last pair. Yeah, not this one, sorry. This one maybe? This one, and rising, yeah. It's the same, and this one. I mean, it's looking okay. I don't see any knocked off capacitors here as well. So let's check a few randomly. 0.81, 81, 81, 81, 81. I will check with the PCI Express lanes tester anyway offline, off camera, but I mean it looks fine to me. Let's check PEX reset. So not this direction. 0.71, so that's fine. And then reference clock 0.8, 0.8. Are these shorted together? No, they are not. So as it stands, the card looks fine. So maybe some voltage is just missing and the card is not starting, so maybe like one of the buck converters is faulty and not producing voltage, or maybe something is missing, not enabling signal or whatever, or maybe we have faulty memory. I don't know. This low resistance worries me, so it may be some memory related issue, or maybe it's perfectly fine. I mean, as I said, I was surprised before by cards like this, so let's try to plug it in and see if we get a picture. Alright, so we have the card connected here. Let's power it on and see if we get the picture. Oh, no power on the power supply. Works better if we switch it on. Okay, it's starting. Let's see. Nothing so far, and well, I know this test bench a bit, and I know when it's starting and when not, so I think we won't have a picture. Let me check the core. Actually, let me adjust the camera so you can see the card and not my head when I will be doing something here. Okay. And the core is not warm, not even warm, so we can safely, I guess, examine it. Let me measure the voltages. What voltages do we have? So starting here, 12 volts from the slot, yes, and from the plug we have 5 volts. We have 5 volts. Do we have core voltage? No, we don't, and that's why the core is cold in the first place. Do we have 1.8? Yes, we do. So probably we'll have 1.8 on the BIOS chip as well. And we have. But since we don't have core, we probably don't have PAX, because that's the last voltage, and we don't have. And we most likely don't have memory voltage as well, and that's the case here. So probably something is wrong after 1.8, I'm guessing, I don't know. Let's try to have a look under the thermal camera. Maybe we'll see something getting warm. Maybe this will give us a hint on why it's not working. Okay, so here's our card, and as you can see, something is getting hot. It's a square thing, so looks like a coil, and this is exactly our 1.8 volts. So even though we have the voltage on it, it's getting warm. So yeah, we have to check what's going on here. And there's also like small tiny point getting hot over here, and that looks to be a resistor. It's not super hot, but it's getting warm definitely. So it's one next to the screw hole. Yeah, it's a resistor. So we can check what's going on here. Okay, so I found a board view that is very similar to my card, and this is for MSI boards, I believe. So my card, basically, this section here looks identical. I don't have this because the PCB is just shorter. It doesn't have this part here, pretty much. So the power connector is like here. So probably this section here is most likely on the other side of the board, but here I checked, everything matches exactly. Almost exactly, but it's like different versions of the same chip, or like newer models or something. But in terms of the pinout and components on the board, it's the same. So getting back to our card, so we said that we saw under the thermal camera that this coil for 1.8 volts is getting warm, but also I had a second look off camera, and I noticed the buck converter also getting warm, the same as the coil. So yeah, you could say maybe the buck converter is not okay, but I have checked also off camera. I found the board, I mean, I have the board view here, but I also checked the datasheet for this chip, and seems like here we have a power good signal. So one thing is that the chip is producing the voltage because we checked it did, but also we have power good signal. So chances that the chip is not good, I would say, are not high. So it's not the most probable cause. So for now, let's assume the chip is fine, it's producing the voltage, it's producing power good signal. I would say it's okay. But if you look at like on this side of the coil, so this is the chip side connecting to the chip, and this is the load side. And as you can see, it's also connecting to the GPU itself and to memories. And we have low resistance on the memory, so it could be caused by either the memory controller in the GPU, that's probable, and that sucks because we basically have a dead card. We have to replace the core if we want to fix it. So not the greatest option. We may have some faulty memory, but if something is shorted, it would be that short, I would assume. I may be wrong, I don't know. But yeah, I cannot tell for sure. I cannot run diagnostics. So if something is short, and also I did like the small voltage injection, and all the memory chips are getting warm like equally. So I don't know. So either the controller is faulty or yeah, I don't know. Uh, so I was thinking, since we have low resistance on memory, let's check the memories, the memory chips and the memory power rail. So here we have the coils for the memory, and here we have two double MOSFETs, which are like parallel, so 12 volts going in here, and that's the output of the MOSFETs here and then here. And the chip that's actually driving those MOSFETs is this one here. So we could do multiple things. We could remove those coils, but those are those like coils with the terminals going through the PCB. I can remove them, but it's probably much more difficult than removing those like SMD coils on the surface that have the terminals on the side. It just requires more like soldering and heating. We could remove those MOSFETs, and that's also an option. And not because the MOSFETs are wrong. I mean, MOSFETs can also be wrong, maybe. But I was thinking, since we have also low resistance here and here, those pins, so this is the output of the MOSFETs, and this is the pin that connects to the driver. Those have the same resistance, and I think that's fine because I checked on another card, which I know is good and has exactly the same layout. So this is actually okay, but the resistance shouldn't be that low. So I was thinking, I mean, maybe it's memory, but let's try to remove this chip because I think it's relatively easy, probably the easiest thing to do right now. And it's not close to any capacitors or anything, so nothing to blow up here, and it's just a small tiny chip, so should be easy to remove relatively. So let's remove it, because maybe, so if we say that the 1.8 is probably okay and it's still getting warm, so maybe something is causing it to draw too much current. Something is drawing too much current, and it's the load is too big on this. So maybe it's something that's attached to it. So that may be actually memory related thing. So let's try to remove this chip and see if it's any better. Also, if we remove this chip and it's causing problems, we should get higher resistance here, I believe, on the memory side. So yeah, let's try and do that. Okay, so we are back, and as you may notice, we don't have the chip that we desoldered driving the memory MOSFETs. But also off camera I have removed the coils, even though I said I don't want to do it, but I did it. it was actually pretty easy if you know how to do it. So remove the coils, and nothing changed when I removed the coils and this chip. So I also removed the 1.8, even though, as I said, I believed it was fine. And still nothing changed. I also did the voltage injection, but well, all the memory chips heat up and nothing on the core. So I would expect if something is wrong with the memory controller, also to see some heat in the corner of the core maybe, or something like this. But nothing like this is happening, and the memory chips just light up slightly, like they are working. So what I did, I actually started searching on the internet, and I was looking for repair videos for this card, and I found a video, like a live video from a year ago, streamed by a Polish YouTuber, an expert in GPU repairs. And he had identical card, I mean identical PCB, identical model from Palit, just it was 1660 Super, not Ti, like mine, but otherwise everything is identical. I think he had different memory from Samsung, I have Micron, but the point is all his measurements were the same, and he had the same fault actually. Well, he had low resistance 5 ohms on memory, but he also had a short on 5 volts. So he found some chip on the other side of the board that was getting hot. He replaced it, and then he got rid of the short on 5 volts, and after that he got 0.9k, exactly like I have. So I have good resistance on 5 volts. I have, well, low resistance on the memory, but what he did after getting rid of the short, he actually powered up the card, and guess what, the card actually worked. So that makes me think that maybe this resistance is actually okay, maybe the memory chips are actually okay. And yeah, let's power on the card like this and see, maybe we can figure it out. Maybe something is getting warm, we'll see under the thermal camera. Okay, so I have powered on the card without the chips I just mentioned, and not sure if it wasn't here before or I missed it, but at the back of the board one chip is getting warm. Okay, so as you could see, this chip over here was getting warm. I think it's for GPU phases. So, and I don't have a replacement for this one anywhere in my donor boards. So, but what I will do, I will remove it for sure, and I will put back all the chips and coils I removed. So if the other chip, the chip on the other side is for the GPU phases, then we will still not have voltage on the GPU, and as a result we won't have any other subsequent voltages like memory and packs, most likely. But I'm curious to see whether 1.8 will be fine now, I mean not getting warm. If that's the case, then that would be an indication that we are going in a good direction at least. under the thermal camera, one of the DRMOS's power stages was actually getting hot for a moment only at the startup of the card, and then I could see nothing, so that's why I probably missed it before. And the problem is this is the SIC 632 chips, and all the board views and schematics are for different have different chips, NCP chips. But I found the board, and so actually some of the pins are different, but I found a datasheet for this chip, and I also kind of probed around to see if this chip that was blinking, so that's the second one here, because we have 4, 1, 2, 3, and 4. So now if we go to the first one, and I found that if we go to the first one and measure the pin number 4 on this side, that's pin 27 by the way, and you can see our resistance is 2.7 mega ohm. Now if we go to our chip, it's showing us what? Oh, sorry, cannot. It's showing us short. And then we go to the third one, pin number 4, 2.7 mega ohms, and the fourth one, oh sorry, not this one, I touched the ground by accident. 2.7 mega ohms. So let's go back to our faulty one, and let's measure it once again. Just make sure we don't touch the capacitor next to it. It's showing short. So I think we need to desolder this one and replace it with something. I don't have the replacement, unfortunately, but maybe if we just remove it, we can see if the card works. Alright, so I have the card connected with the DRMOS desoldered. Let's power on the board. 1 second. Here. And do we have core voltage? We have, and we have pegs, and that means we also have memory, most likely 1.3. And guys, we also have a picture. Okay, and we are in Windows now, and as you can see we have NVIDIA GeForce GTX 1660Ti. Also in GPU-Z we have 6 gigs of GDDR6 from Micron. The chip is fine, all the technologies here are checked, so everything works as expected. Temperatures are okay. I used old thermal paste, the remains of it actually, so I need to clean the card because it was a little bit dusty, the heatsink and everything, and then we'll repaste it, change some thermal pads, maybe all of them if needed, and yeah, that's it. I mean, I'm not gonna torment the card right now because it's lacking one DRMOS, so I don't want to cause any issues, but looks like everything is fine. So once I replace the DRMOS, I will retest the card, of course, make sure there's no shorts, but we should be good. Okay, powering on the motherboard, and let's check if all the phases work correctly. So check the previously working phase. We have a signal, and here, and here, and here. And we also get a picture. So the card is ready to be assembled. As you can see, I have run TimeSpy without any issues. We have the score here, so for this card I would say it's typical. And also the temperatures, we had maximum of 72 degrees Celsius on the GPU and 84 on the hotspot. Considering how small and you know, and because it has one fan only, I think it's fine. It's quite decent score for this card, and the temperatures are okay. So yeah, I call it a fix, and the card is ready to go. And it took me quite some time to actually figure out the fault, mostly because the resistance on the memory was so low, and then finally I found the faulty DRMOS. So yeah, quite unusual repair, I would say, because I would expect the DRMOS to be shorted to 12 volts, and it was not the case. There was no short on 12 volts, yet the DRMOS was faulty, causing some issues and at the startup. So yeah, that was a bit unusual and interesting, I believe. Thank you for watching. Leave a like if you enjoyed the video. Let me know in the comments what you think about this repair. And since you made it till the end of the video, I'm pretty sure it's worth smashing that subscribe button.